Okay, guys, now let's look at exercise number 2, which is prescriptive maintenance using time series forecasting. So what we are going to do, we have a list of equipments and which needs maintenance scheduling, and you go to forecast, you go to do some you have some data list of historical maintenance or historical data, failure rates, and maintenance schedule and operating informations. So we have that set of tool which we you can download from Canvas, use that into your Power BI, upload it into Power BI. Now we are going to see how we can forecast model in Power BI and to determine when to schedule maintenance for your construction equipment and optimize better cost decision. Go to your Power BI. I've already downloaded the maintenance sheet, the prescriptive maintenance, and I can see the list of all data which have already loaded into Power BI. So after you load the data, just check into your table view and see how your data is looking. Your equipment ID, your last maintenance, and change it as date if you want. It's already been changed, so I'm keeping it as such. And with that, we'll go to the next step. So we go to create a time series line. So let's go to line chart view, insert a line chart. This is your line chart, just insert it, maybe expand it a little bit, and then in your x-axis drag your date hierarchy, either your last maintenance, or can have your historical failure rate, whichever you want to see. You can drag and drop it in your x-axis, historical failure rate, and in your y-axis use your failure rate. That gives you the information in that thing. And use the legend to add. In the legend it's kind of optional, but if you want to use it, use legend equipment ID into your legend field and see what you get. Oh, that's gives you different equipment ID as well, but it confuses at this time. We don't do that now. Let's take it out. And now the next step is to apply forecasting. So this is the core part of your exercise, how you're going to forecast beyond 38. So in that, select this line chart and go to your analysis plan, which is your the analysis icon here, which is your magnifying glass. Just click there, and here look for forecast. In the drop down list we got forecast. Just click forecast and make sure it's on. You want to forecast, so it's forecasting for the next, say, 20 years or so. So under forecast, you have number of options. I want you to configure only the forecast length, which we can have it with forecast length for 30 days or something instead of 10. So just make it 30, and don't worry about the ignore the last. Seasonality is going to be auto in that. Confidence level, keep it as 95, and just apply and see what you get. So yeah, so it's forecasting for the next how much, 10, 20, 30, or 40 plus years. uh, Power BI uses exponential smoothing, ARIMA style logical internally. What you'll see is the black line, which is kind of a forecast line. So it's what it's going to forecast, and it gives you the 95% confidence whether it's upper or lower limits. That's what your confidence level is. So now we go to maintenance should be scheduled when failure rate is increasing sharply and forecast crosses a risk threshold. So how do we create a threshold measure? Let's go back to the data set and look for new measure. In the new measure, what we are going to do is to do a maintenance required or maintenance request with a failure threshold of 0.8. For example, we'll give that, and flag high risk period. So let's make it as maintenance and required equals, it's an if scenario, right? If the average of your failure rate, close bracket, is greater than your failure threshold. Failure threshold is, we'll put failure threshold as 0.8, then yes. If not, no. Oops, just have to change to English. So failure rate is 0.8 is yes. Come on, else no. Then close. So that's your first measure request. So you've done that. Use this in this table and conditional formatting if you want. Um, yeah. And is there a hello? X-axis, Y-axis lines. Yeah, fair enough. So the next step is to predict optimal maintenance schedule. Create a simple logic. In this, if your failure probability is high, schedule a maintenance. So you got to create a um, new measure. Let's go and create a new measure here, which is going to be maintenance decision. Maintenance decision equals if on average your failure rate is greater than 0.8, you got to schedule your maintenance. If not, it's a normal operation. Yes. And then close it, and you have created a new maintenance decision here. And the next step is to do a cost analysis measure. Now compare the cost across each equipment. So to do the total maintenance cost, you got to create a new measure again, create new measure, and now it's total maintenance cost equals, it is your sum of your maintenance cost, close bracket, and that's your sum of maintenance cost is your total maintenance. Then you have to have another measure, which is your cost per equipment. Cost per equipment, cost per equipment equals the sum of maintenance cost, and then close bracket, comma, with all, oops, comma, all except your table IN, comma, and the equipment ID, equipment in expect table, and that's the equipment ID. Equipment ID, and then close bracket, and that's it. You created, I think there's one. Okay. Where's it wrong? Two, maybe. Operation expression is not reported. I think I made some error. Let's do it again. Or except IN, comma, IN equipment, close bracket. Working on it. this here. Oh, so you got to calculate. You just forgot this adding the calculate. So you go to calculate and then add your sum in maintenance cost and all except your equipment ID. And then make an enter. It's already created there. And if you want to do a cost efficiency, you can still do a cost efficiency, which is just your optional one. So let me also do a cost efficiency. So create a new measure and look for cost efficiency. So cost efficiency is nothing but you got to use divide function and then create sum maintenance cost and then close bracket comma and sum your failure rate and then close bracket, and that gives you the cost efficiency. So it gives you, whatever, if it's lower, your better efficiency. So now let's do and create some line chart, or using or bar chart to see how your failure rate over time and forecast, which is you have already done it, which is your failure rate over forecast. And if you want, you can do a bar chart with your equipment ID and cost. Let's see if you can create a bar chart, clustered bar chart, and use probably your equipment ID as your x-axis, and then your maintenance cost on your y-axis, and you have, and if you don't want to see it this way, you can change your stacked, and then you can have your maintenance cost, or the other way around. If you want to use this and then change it, yeah. So you'll have your maintenance schedule for your um, maintenance cost for each of your equipment can be shown in this one. So that's how you create your flow chart or visual representation, and here you can have all your visual representation of how your maintenance should be depending on the forecast, and what's your lower and upper bound for the next 20 plus years or something. That's your forecasting of time series using Power BI.